So, a ball thrown vertically upward with a velocity of 45 meters per second. Initial velocity, 45 meters per second. Okay, our final velocity at the very top of a throw is always going to be 0. We know on the other side, when it's coming back down, our initial velocity is going to be 0, and then our final velocity is just going to be negative whatever it was that it was thrown up at. Okay, so that's how that works. Because our throw will look like this on a position versus time graph. It'll stop here at the top and then fall back down. And so our total time will include an up and a down. Okay, and that's why we analyze these problems in two pieces. Anyway, so how long does it take to reach its highest point? Well, we know our acceleration, and let's go, since we've already defined that down is the negative direction, let's go ahead and say that our acceleration is negative 9.8 meters per second squared. So we're just going to do our delta v, which is equal to our acceleration multiplied by our time. Our delta v is from 45 to 0, so negative 45 equals negative 9.8 multiplied by however much time that would take. So 45 divided by 9.8, or a total or a time to the top of 4.59 seconds. And our total time for that whole thing is 2 times that, or 9.18 seconds. 9.18 seconds. How high does it rise? How long does it take? How long does it take to hit the ground after it reaches what is velocity? Okay, so what is this velocity when it returns to the level from which it started? We already solved for that. That was just 45. How long does it take to hit the ground after it reaches its highest point? Again, it falls for the same amount of time that it goes upwards, so 4.59 seconds. And how long does it take to reach its highest point? Again, 4.59 seconds. That's how long it takes to slow down. Now, the last interesting question in this is how high does it rise? So initial velocity plus 1/2 delta v delta t, right? Our initial velocity is 45, and we know that it rises for 4.59 seconds. Plus 1/2 negative 45 multiplied by 4.59 seconds. So more or less just 1/2 of 45 times 4.59 seconds, which equals 103.275 meters. Okay, so like I said, total time up and time down, how high does it rise, and how fast is it moving when it hits the ground. All those things are there.